Welcome back, folks. In today's class, I'll be talking about chapter number 5.2, and in 5.2, we'll be talking about mutually exclusive versus non-exclusive event. So, mutually exclusive event there in which the two events there is nothing common between the two events. So, this is event A and this is event B. There is nothing common. For example, in a school, 100 students have enrolled, and 50 of them have are studying stat. Let's say A is stat and B is math. So, and 50 students are enrolled in the math course. So, there's nothing common between them. So, 50 plus 50, there is total number of students is 100. So, that's called mutually exclusive event. Now we will talk about non-exclusive event. They are a little tricky compared to the exclusive events. So for example, if I were to draw the diagram for the non-exclusive event, it will be A and then like this B. So there is always some sort of a sharing ground between A and B. So those kind of events are called non-exclusive events. We will try to understand it with the help of an example. So first of all, please make sure you pay attention to the wording also. uh, there are 75 students who are studying math or stat. Okay, I use the word or, so means they can be studying math or stat. Their total number of students are 75. Now I'm gonna say 50 students are enrolled in math and 50 students are enrolled in stat, but the total number of students who are studying math or stat are 75. Okay, I wanted to find out how many students are studying math and stat. So and section becomes, this is the and section. If I were to draw it with the different color, this is the and section. This is math, whoops, math and stat, I will call it, and stat. Okay, and this whole thing is math or stat, math or stat, and this is represented by M union S, and this is represented by M intersection S. That's how you're going to represent it. So please make sure you understand the difference. Now, there are total number of students who are studying math or stat are 75, and 50 of them are studying stat, 50 of them are studying math, and minus how many of them are studying math and stat, and that we can easily figure out now. So 75 equal to 100 minus math and stat. This is, I'm going to move it on the other side. 75 minus 100 equal to minus math and stat. This is equal to minus 25 equal to minus M and S. That cancels out. So math and stat is equal to math and stat is 25. That's your answer for this question will be. So this kind of a question, if you see, that is an example of non-exclusive events in which there is always some kind of a overlap or sharing between the two events. Now we will try and understand this question with the help of the Venn diagrams. So in this question we are given, let me just fix it. No, I couldn't fix it. We are given a company is planning to launch two new products, product A and product B, and is contemplating their profitability based on some market analytics uh, of similar products. It was determined that the probability of profitability was 74% for product A, 69% for the product B, and 55% for for both of the product together. Present the information in the Venn diagram form. So if I draw a Venn diagram, so because this is a question on the probability, so please make sure your sum of the probability should come out to be equal to 1. And this product A is 74%, so I will draw the product A. This is 0.74, and product B is 69%, and there is a overlap between the two also. 69%, this is 0.69, and because there is an overlap between the two of them, so this section is 0.55. And if I were to do the math on these together, so let's see what the remaining section will be equal to. So because the total probability I told you should be 1, means this whole section should come out to be 1. So 1 minus this section. First of all, I have to find this section, and I have to find this section and this section separately to find out what is the value of the outside section is. So if this whole section is 0.74 and this section is 0.55, this remaining section will become how much? So you guessed it right, 74 minus 0.55. This will become equal to 0.19. So only A. And this section, let me highlight it also. This section which I'm coloring with the blue, this section is also called only A. Only A. And this section, which again I'm coloring with the blue, is called as only B. Only B. Now I'll request you guys to pause the video and try and find out only B. Hopefully you were able to find out the section B. So total B is equal to 0.69. That's what is given to us in the question. Let me show you one more time here. This is 69% for product B. And I am trying to find out this section now. So this will come across as only B, which is equal to 0.69 minus 0.55, which is equal to 0.14. So, well, this is 0.14, the section which I'm coloring now. All right. And this section is 0.55. So 0.19 plus 0.55 plus 0.14. If I were to do the math on my calculator, it will come across as 0.19. Oops, say 0.19 plus 0.55 plus 0.14, 0.88, which is 0.88, and total is 1. So 1 minus 0.88 will give me 0.12. So this section of the Venn diagram, the outside section, which I'm going to color with the green. So this section is 0.12. Okay. So we've drawn the Venn diagram, and now we're gonna try and answer some of the questions in this one. And let's see, what is the question number 1? Determine the probability of each section and the event, and oops, and the shared region that's satisfying on the Venn diagram. So again, this 0.12 is the neither A nor B section. Now we gonna, let me just fix my pen. 1 second. Yeah, we're gonna answer the part B. And product B will not be profitable. If product B is not profitable, that's what we're trying to find out. So product B, the profitability of the product B, that was this whole section. This was 0.69. So product B, except every other than product B. That means product B will not be profitable. Product B will not be profitable. So that will be total probability is 1 minus 0.69. That will be 0.31. So probability of product B profitable was 0.69, and probability of product B not being profitable is 0.31. And only product A is profitable. I think you guessed it right. That is 0.19. We've already done that. And at least one of the product is profitable, means A or B, at least one of them is profitable. So this whole section, let me again change the color. And this, oops, let me thicken up the pencil. This whole section, A or B. So A or B is equal to probability of A plus probability of B minus probability of A intersection B, because A intersection B is repeating itself. This section is repeating itself twice. while calculating A, while calculating B. So this section is repeating twice, so I have to subtract it once. So 0.74 plus 0.69 minus 0.55, which is A or B. A or B, which comes across as, this number will come across as 0.88. So this is 0.88. Neither product A nor B will be profitable. So neither A nor B, as I told you, this outside region, that is 0.12. And then the next part is only one of the product is profitable. Either A is profitable or B, not this union part, this intersection part, common part. So this portion I have to, oops, say, this portion, the one which I am trying to color with the black, this portion I have to subtract. So this is gonna be a 0 point, well, it will be 0.19 plus 0.14. That will be the answer for that portion. 0.33, only one of the product is profitable. No more than one product will be profitable. No more than one will be profitable. So it means zero product plus one product. So either A, either A or B, you know, either A is profitable or B is profitable, plus, not shall, or plus B. Yeah, I guess you got it. You know what I'm trying to say. Zero product is profitable means 0.12. 0.12 is the profitability for the none of the product is profitable. That is the probability for none of the product being profitable. And for product A, only product A being profitable will be 0.19. And what is the probability that product B is profit, only product B is profitable? Only B is profitable, 0.14. If both are profitable, then the two product will be profitable. So then we won't be able to satisfy this, no more than one. Then it is only A plus only B. I should write it. Okay, so you add three numbers, that's going to give you the answer for the final part. That will come across as 0.45. So 0.45. So hopefully you were able to understand how to simplify these questions. Uh, Now I'm gonna try and do this same question with the help of two-way diagram, because two-way diagram is the most important thing to learn to solve some of these questions which I'm gonna give you to practice. So what did I tell you? What is given to us in the question? I'll try and rewrite it. Probability of A was 0.74, probability of B was 0.69, oops, 69, and probability of A intersection B was equal to 0.55. Now how does two-way table work? So here I will write the probability of event A, and here I will write the B. In two-way table there will always be two events, and probability of event B, oops, and not B bar, let me erase this. Yeah, and here I will write down P A bar, and here I will write P B bar. You can also make the table, you can, what I'm trying to say, you can interchange the position of A and B also. You can write it as, down here you can write it as PB, and this is PB bar, and this PA and PA bar. That's how you can write it also. All right, and now one more thing I want to tell you: when you're drawing a two-way table, you, the sum of all the values should come out to be one here. Sum of all the probabilities should be one here. Okay, means from this side if you add the values, if this side you should add the values, this should come out to be one. So what is the probability of event A? This is, I'll write it here, 0.74. Probability of event A not occurring, so 1 minus, this is 1, 1 minus 0.24, 0.74 is 0.26 if I'm not mistaken. And probability B is equal to 0.69 and 0.31. This is going to become, because the sum has to be 1 here. So 1 minus 0.69 will be 1. Now this section is called P A intersection B. Okay, and this section will be, because these two are together, and then this section will be A B, sorry, here I will write PB intersection A bar. That's what I'm gonna write it here. And here I will write it as PA intersection B bar. And here I will write it as PA intersection B bar. That's how I'm gonna write it. So combination of these two, this one is combination of this one and this one. This one is combination of this and this. I don't want it to add too many lines, so hopefully you were able to understand. Otherwise I have to erase, and it's gonna now create a lot of hodgepodge. uh, Erase it, please. It's starting the Copilot, which I don't want. Whoopsie. Draw. Finish it. Right. Now we're gonna try and find the value of A and B. A intersection B is given to us. That value is 0.69. So you will always find one of the values inside the boxes will always be given to you. And this value is 0.55, which is given to us. So if this is 0.55, I can always find this value, because total is 0.74. So 0.74 minus 0.55, which is 0.19. And then this is 0.26, and this will come out to be, uh, if this is 0.55, this is 0.69, I can find this value. So 0.69 minus 0.55. So 0.69 minus 0.55, which is 0.14. And this one will be, if this is 0.14 and this is 0.26, so this will be 0.12. And if I add these two, this should come out to be 0.31 on the other side. This proves that our math is correct. Now the good thing is we should also be able to read this, and we need to understand how to read this. And if I write A intersection B, we know that this means the common section between A and B means both A and B. This means both A and B. That's the meaning, A and B. And the meaning of probability A intersection B bar, what is the meaning of that? That means only A, because that was the probability for only A section. If you're going to go back in here in the diagram, you will be able to see this section was 0.19. Okay, and this section, so the same way this section will become only B, and this section will become neither A nor B, neither A nor B. Okay, this section is PA, this section is A naught as mentioned here, and this is PB, this is B naught, and the total probability is 1. So this is two-way table, which you will use it to solve a lot of questions. So I'll highly recommend you to understand the two-way table, because that's gonna make your life very easy. You don't need to understand any Bayes theorem or any other thing. Contingency table, this is what I'm talking about. That is on page number 254. So this, or try and understand this thing, because this will really help you to solve some of the questions later on, especially when we'll talk about dependent and independent events. So that's it for today. I'll see you with the last video. And till then, goodbye.